Have you ever done that? You send some crypto and then you just wait and you wait and you're just staring at your screen, watching your transaction just sit there unconfirmed. It is so frustrating. It's a super common experience, but why? Why does it actually happen? Okay, let's get into it and really unpack the mechanics behind Bitcoin's big waiting game.
And that's such a great question, right? Because that is literally what it is. It's a traffic jam, but it's a traffic jam with some, let's say, very unusual rules of the road. To really understand how this digital gridlock happens, we've got to pop the hood and see how the Bitcoin network is actually processing your payment.
All right, to make this all make sense, we're going to use an analogy. Let's just forget all the computers and the code for a minute. Instead, I want you to imagine the entire Bitcoin network is just one single, kind of peculiar coffee shop that the whole world has to use.
So every time you send some Bitcoin, you're essentially just a customer walking into this global coffee shop to place an order. Simple enough, right? But here's the thing. This shop has some very, very specific rules about how it serves people.
Okay, so let's get our terms straight for our little shop. You, the customer, are a transaction. The cashiers, the ones processing all the orders, we're going to call them miners. Now, they don't handle orders one by one, no. They group them together into these big batches called blocks. And while you're waiting, you're standing in this huge waiting area called the mempool. And once your order is finally processed, it gets permanently stamped into a giant public receipt book. And that is the blockchain.
Now, this is where our coffee shop analogy gets, well, a little weird. To process a batch of orders, our cashiers, the miners, don't just ring them up. They all have to compete to solve this incredibly difficult math puzzle. The first cashier to solve it gets a reward, and they get to process their entire batch of orders. This whole crazy competition, that's what we call mining.
And this right here, this is the most important rule in the whole coffee shop. It's the one that causes all the traffic jams. That puzzle, it's designed to take, on average, 10 minutes to solve. That means a new batch of orders, a block, only gets processed every 10 minutes. It doesn't matter if there's one person waiting or a million people waiting. The shop runs on a strict 10-minute schedule, period.
So let's quickly recap your journey as a customer in this shop. 1. You place your order. 2. You go into that big waiting room, the mempool. 3. You wait around, hoping a cashier picks your order for their next 10-minute batch. 4. They solve the puzzle. And 5. Confirmed. Your order is processed and stamped into the big receipt book. But what makes a cashier decide to pick your order and not someone else's?
And that brings us to the next crucial layer of our peculiar coffee shop. You see, this line, it is not first come, first served, not even close. It's more like an auction. Our cashiers, the miners, are all about making money, so they don't just pick orders at random. Oh no, they prioritize.
So, you've basically got two types of customers. On one side, you have the high-priority folks. These are the people who attach a bigger tip, what we call a transaction fee, to their order. The cashiers see that bigger tip, and you guessed it, they're way more likely to grab that order first. It's like a priority pass. Then you have the low-priority customers, maybe making a tiny payment and they attach a really small fee. Well, they get pushed to the back of the line.
And this isn't just theory, okay? This priority system has a dramatic real-world impact. This data here comes from a 2018 analysis of the Bitcoin network. Now look at the high priority wait times. See how they stay pretty consistent, right around 17-18 minutes? But now, look at the low priority transactions. Between 2014 and 2015, as the network got busier, their average wait time more than doubled. It jumped from about 30 minutes to a staggering 81 minutes.
So that huge gap is exactly what researchers wanted to figure out. They decided to build a mathematical model of this whole system, to basically stress test our coffee shop, to pinpoint exactly where and why the line breaks down when it gets put under pressure.
4,887 seconds. This was the number that really just jumped off the page. This was the canary in the coal mine. It was signaling that something about this system was creating a totally separate, two-tiered experience for its users.
I mean, really think about that. An hour and 20 minutes, on average, just to make a small payment. So the researchers wanted to know, is this the new normal? And what on earth happens if the network gets even more crowded? Are those wait times just going to keep climbing up forever?
So what did they find? Well, the mathematical modeling uncovered two key bottlenecks, two main ways that our coffee shop's line just grinds to a halt, but only for certain customers. First,
There's the block size effect. Remember how our cashiers can only process a limited number of orders in each 10-minute batch? Well, the research confirmed what you'd probably guess. When the shop gets really busy, having a small batch size is a huge problem. It's like having a tiny little tray to carry orders when there's a massive crowd. So a bigger tray, a larger block size, definitely helps reduce the overall weight for everyone.
But the second finding, this one was way more important. It's what they called the micropayment effect. And get this. The models show that when there's a flood of low-priority customers, all these people trying to make small payments with tiny fees, the wait time for the high-priority customers barely changes. They keep zipping through. But for that low-priority group, their wait time doesn't just go up, it skyrockets, basically towards infinity. They get perpetually stuck in the waiting room.
So here's the crucial point, the main takeaway. Making the batch size bigger, or in real terms, increasing the block size, is like giving our cashiers bigger trays. It helps manage the crowd, sure, but it does absolutely nothing to fix the underlying priority system that leaves those low-fee transactions in the dust whenever things get busy.
And this brings us right to the core conclusion from that 2018 thesis by Yoshiaki Kawase that this whole explainer is based on. He concluded that, yeah, increasing the block size helps a bit, but it is not a silver bullet. It doesn't solve the fundamental scalability problem, because that priority queue system is still there.
And so, this leaves us with a much, much bigger question, one that really goes beyond the technology. Bitcoin was imagined as this decentralized financial system for everybody. But what the research shows is that when it's under stress, its very structure creates a high-speed VIP lane for those who can pay and a potential never-ending traffic jam for others. It really forces us to ask, if a system is truly built for everyone, how can it avoid leaving some people stuck in the waiting room forever?